Hello viewers, in today's session we are going to discuss another important problem from derivatives, right? And in this class we'll discuss this problem which is related to functional equations. So here we are given this equation, that is f of x plus y over 3 is equal to 2 plus fx plus f of y divided by 3 for all values of x and y belonging to the set of real numbers. And here we are given that the value of the derivative, that is f prime at this point, that is e square, where e is the exponential number, f prime of e square is equal to 2. Then we have to find f prime of pi square and f double prime, that is the second derivative at this point, that is e square. So here we have to find f prime of pi square and f double prime of e square. So it implies that we have to find the form of the function that is f of x. So our aim is to get the expression for the function that is f of x. So what we will do, we'll take help of the concept of partial differentiation. So we are given f of x plus y over 3, and this is equal to 2 plus f of x plus f of y divided by 3. So let us write this expression as 2 by 3 plus f of x, and here we have 1 over 3, and then we have 1 over 3 f of y, and here we have f of x plus y over 3. So now what we will do, we'll differentiate both sides partially with respect to x, right? So partially with respect to x, and we'll take y as a constant. So now we can write del of del x, and here we have f of x plus y over 3, and then we have to find the derivative of this expression with respect to x. So we have 2 by 3, then we have 1 over 3 derivative of f of x, and then we have 1 over 3 the derivative of f of y. Now here we have to find the derivative with respect to x of f of x plus y over 3. So first we have f prime of x plus y over 3, and then we have to differentiate this expression, that is x plus y over 3 with respect to x by chain rule, right? So this is now equal to 0, because 2 by 3 is a constant. So the derivative of 2 by 3 with respect to x is 0. And here we have 1 over 3. And this is f prime of x. And then we have 1 over 3. And see f of y. This is an expression which contains y only. So we have to find the partial derivative of f of y with respect to x. So y is, we are treating y as constant, so the derivative must be equal to 0, right? So we have f prime, and here we have x plus y over 3, and now we have 1 over 3, and we have to find the derivative of x plus y. So we can now write del over del x. Here we have x, and then we have del by del x of y, and here we have, this is 0, this is 0, so we are left with only 1 by 3 f prime of x. Now the derivative of y with respect to x is 0, because we are treating y as constant, and here the derivative of x with respect to x is 1. So we have now this equation, that is f prime x plus y over 3, and here we have 1 over 3, and this is 1 plus 0, and here we have 1 over 3 f prime of x. right? Now 1 over 3 and 1 over 3 get cancelled, so we have f prime of x plus y over 3 is equal to f prime of x. So after differentiating this equation partially with respect to x, we have arrived at this important equation, right? So here what we will do, we'll replace x by 0. So we have now f prime of 0 plus y over 3, and then we have f prime of 0. So this is f prime y over 3, and here we have f prime of 0. Now let us replace this y by 3x, right? So we have f prime, and here for y we can write 3x, and here we have 3, and this is equal to f prime of 0. Now 3 and 3 get cancelled, so we are left with f prime of x is equal to f prime of 0. Now this is an important result. So now this is an important result which suggests that the derivative is equal to a constant, because see, f prime of 0 is a constant and f prime of 0 is equal to f prime of x, because f prime of x is a function of x, and a function of x is equal to f prime of 0, and f prime of 0 is a constant, so it implies that f prime of x can be taken as equal to k, where k is some constant. So this k is now equal to f prime of 0. So now here we are given that f prime of e square is equal to 2. So if we take here x is equal to e square, then this equation gives us f prime of e square is equal to k is equal to f prime of 0, right? And f prime of e square is given as 2, so we can write 2 here, and we have k, and this is f prime of 0. So now from here we see that the value of k is equal to 2, and f prime of 0 is also equal to 2. So let us substitute this value of k is equal to 2 over here. So we get f prime of x is equal to 2. Right? Now this is a differential equation. F prime of x is equal to 2. It means this is the d by dx of f of x, that is equal to 2. So if we integrate both sides with respect to x, we'll get d by dx of f of x dx, and here we have integral 2 dx, and c is the constant of integration. So here we have simply f of x, and here we have 2 integral dx plus c. So this is 2x plus c. So we have obtained the function f of x, which is equal to 2x plus c, and we can see that this is a linear function. So now to get the value of c, we can take x is equal to say 0, right? So when we take x is equal to 0, we have f of 0 is equal to 2 times 0 plus c, and this is f of 0 is equal to c. So now f of 0 is equal to c, and to get the value of f of 0, we can make use of this equation, right? So taking x is equal to 0 and y is equal to 0 in this equation, we have f of 0 plus 0 over 3, and then we have 2 plus f of 0 plus f of 0 divided by 3. So taking x is equal to 0 and y is equal to 0 in this entire equation, we have now this expression. So 0 plus 0 is 0, 0 over 3 is 0, so we have f of 0. Here we have 2 plus f of 0 plus f of 0 is 2 times f of 0, and here we have 3. Now multiplying here by 3, we have 3 f of 0 is equal to 2 plus 2 times f of 0. Now taking 2 times f of 0 to the left hand side, we have 3 f of 0 minus 2 f of 0 is equal to 2. So subtracting these two, 3 minus 2 is 1, so we have f of 0 is equal to 2. So taking f of 0 over here, the value of c is equal to 2. So now our function f of x is equal to 2x plus 2, and this function is a linear function, right? So we have obtained the form of the function, and the form of the function is a linear function which is of the type ax plus b, right? Okay, so now we have to find f prime of pi square and f double prime of e square. So now from this equation, we can see that f prime of x is equal to 2, and 2 is a constant. So the derivative is a constant function, right? So when we find out the successive derivatives, that is the second derivative, then the second derivative is 0, because the derivative of 2 with respect to x is 0, because 2 is a constant, right? And similarly the third derivative is also equal to 0. So f prime of x is equal to 2. So to get the value of f prime of pi square, then f prime of pi square is also equal to 2, because f prime of x is a constant function, and in other words we can say that f prime of x is independent of x. So whatever be the value of x, f prime of x is always going to give us 2, right? So f prime of pi square is 2, and f double prime of e square is equal to 0, because all the successive derivatives are 0, right? So viewers, this is how we can solve these type of problems. Hello viewers, in today's session we are going to discuss a very important and conceptual problem from differentiation and functional equations, right? So here we have a mixed problem on differentiation and functional equation, and the problem goes like this. If we have a function f from the set of real numbers to real numbers, and this function is given to be a differentiable function, and f of 0 is not equal to 0, and f satisfy this equation, that is f of x is equal to f of x minus y times f of y for all xy belonging to the set of real numbers. And in addition to this, we are given that f prime of 0 is equal to alpha plus 1, and f prime of 2 is equal to beta plus 1. Then we have to find the derivative of this function f at minus 2, right? And here alpha and beta are not equal to minus 1, right? So let us see how we can solve this problem with the help of partial differentiation. So let us start with this equation, that is we are given f of x is equal to f of x minus y, f of y for all xy belonging to the set of real numbers, right? So let us first take x is equal to 0 and y is equal to 0, right? So we'll get f of 0, and here we have 0 minus 0, that is 0, and here we have f of 0. So we have f of 0 is equal to f of 0, and here f of 0 times f of 0 is f of 0 square. We can take f of 0 to the left hand side, so we have f of 0 and square, and this is equal to 0, right? Now taking f of 0 common, we have 1 minus f of 0, and since we are given that f of 0 is not equal to 0, so it implies that this factor must be equal to 0, that is f of 0 is equal to 0. So we have f of 0 is equal to 1, right? So the first step is to get the value of f of 0, that is equal to 1, right? So this is our first step. Now we can make use of the concept of partial differentiation to solve this problem. So the second step is to differentiate both sides partially with respect to x, right? So we'll take the partial derivatives of both sides with respect to x. So we have del of del x of f of x, and here we have del of del x of f of x minus y, and here we have f of y, right? So when we take the partial derivative, then we can treat this y as a constant. So here we have the derivative of f of x, so this is f prime of x, and here f of y is a constant because we are differentiating with respect to x. So we have del of del x of f of x minus y, right? So we have f prime of x, here we have f of y, and now first we differentiate f, so we have f prime of x minus y, and then by a chain rule we'll differentiate this factor, that is x minus y. So we have f prime of x is equal to f of y, f prime of x minus y, and here the derivative of x with respect to x is 1, and the derivative of y with respect to x is 0, because the y is treated as constant. So here we have 1, right? Okay, so now here we have this equation. So what we will do, we'll take x is equal to 0 and y is equal to 2, because we have to find the value of f prime of minus 2. So let us take x is equal to 0 and y is equal to 2 in this equation, so that we can get f prime of minus 2. So now taking x is equal to 0 and y is equal to 2 in equation 1, we have f prime of 0, then we have f of 2 and f prime of x minus y. So we have 0 minus 2, that is this expression, right? So f prime of 0 is given as alpha plus 1, and here we have f of 2, and this is f prime of minus 2, right? So f prime of minus 2 is now equal to alpha plus 1 divided by f of 2. So the value of f prime of minus 2 is equal to alpha plus 1 over f of 2. So now we need to find out the value of f of 2, so that we can get the value of f prime of minus 2 in terms of alpha and beta. So now the third step is to differentiate this equation partially with respect to y, right? So first we have differentiated both sides partially with respect to x. Now we'll differentiate both sides partially with respect to y. So now we can write del of del y, and here we have f of x, and then we have del of del y, and here f of x minus y, f of y. right? Now see, in the left hand side we can see that f of x is a function of x only, and here we have to differentiate f of x with respect to y. So we are now taking x as a constant, right? So the derivative of f of x with respect to y must be equal to 0, because when we differentiate partially with respect to y, x is treated as a constant. Now here we have the product of two functions, and both these functions contain y. So we'll apply the product rule. So first we have f of x minus y, then we have the derivative of f of y, and then we have f of y and derivative of f of x minus y. So here we have used this result, that is d by dx of uv, where u and v are functions of say x. Then the product rule says that first we have u, then we have dv over dx, then we have v and du over dx. So now we have 0 here, f of x minus y. The derivative of f of y with respect to y is f prime of y. Here we have f of y. Then the derivative of f is f prime of x minus y. And then by chain rule, we have the derivative of x minus y. So we have 0, then we have f of x minus y, f prime of y. Here we have f of y, f prime of x minus y, and here the derivative of x with respect to y is 0, because x is constant, and the derivative of y is 1 with respect to y. So here we have 0 minus 1, so we have simply minus 1. So now we can take this negative sign over here. So now we have f of x minus y, f prime of y minus f of y and f prime of x minus y, that is equal to 0. So now we have this important equation. So now let us take x is equal to 2 and y is equal to 2 in this equation. So we have f of 2 minus 2, then we have f prime of 2 minus f of 2 and f prime of 2 minus 2, that is equal to 0. So this is f of 0, 2 minus 2, 0. Here f prime of 2, then f of 2, and this is f prime of 0, and this is equal to 0, right? Now f of 0 is equal to 1, so here we'll write 1. Then we have f prime of 2. Now f prime of 2 is given as beta plus 1, and here f of 2, and then we have f prime of 0, and f prime of 0 is given as alpha plus 1, that is equal to 0. So now we can write beta plus 1 minus alpha plus 1, f of 2 is equal to 0. So this is beta plus 1. Taking this term to the right hand side, we have alpha plus 1 and f of 2. So f of 2 is equal to beta plus 1 over alpha plus 1, right? And see, f prime of minus 2 is equal to alpha plus 1 over f of 2, and we have obtained the value of f of 2 in terms of alpha and beta. So f of 2 is the ratio of beta plus 1 and alpha plus 1. So let us substitute this value of f of 2 in this equation. So now f prime of minus 2 is equal to alpha plus 1, and f of 2 is beta plus 1 over alpha plus 1. So we can take alpha plus 1 to the numerator. We have alpha plus 1 over beta plus 1 times alpha plus 1. So this is alpha plus 1 square. Alpha plus 1 times alpha plus 1 multiplied together gives us alpha plus 1 square, and here we have beta plus 1. So the value of f prime of minus 2 is given as alpha plus 1 square divided by beta plus 1. So this is how we can solve these kind of mixed problems on differentiation and functional equations.